ocean is a really big place. Particularly the Pacific Ocean is a really big place. So even big docks that are floating around after the Japanese tsunami are tiny, tiny little fragments in the entire North Pacific Ocean. And one of the things that happens is the North Pacific, any ocean, is not just a bathtub, right? It's something where the water is moving around, and the water tends to move around the edges much faster. Those are the coastal currents. And in the center, it moves slower and slower. So like a Cuisinart, like a Tasty Freeze machine, all of that stuff right in the middle is going to circle around very, very slowly. And that action acts to trap a lot of the debris. So we end up with something that we call the garbage patch, which is that center, and debris may hang out in that garbage patch not just for months, but for years. And seasonally, as the wind patterns change, big aliquots of that water, hundreds of kilometers wide, will break off from that garbage patch and slam into the coastline and may cover a range that's Oregon and Northern California. So we tend to see lots of debris come in, predominantly in the fall and winter when we have patterns of surface water movement into the coast. And then we tend to see less in the summer and early fall when the water is going in the opposite direction. So we are hoping to see all sorts of really interesting things. Just like the birds, there's a seasonal pattern to debris, and we want to know what it is. We want to be able to document that. And we want to know whether pieces of debris that are coming from particular areas in the ocean, but originally from the land, grace our shores at different times of year. So everybody thinks that everything they find is part of the Japanese tsunami. But in fact, lots and lots and lots of debris before and after and during the tsunami are from different places. Falls off of boats, gets swept out of rivers, comes from the land. And the thing about it is not where it comes from so much, but how long does it last? And that's the amazing thing. I mean, there are pieces of debris that have been in the water for years to decades. We're still finding Japanese glass fishing floats that haven't been used actively in fisheries for decades. One of the things that Coast is doing right now is we're starting a whole new data collection module in marine debris. So lots of people out on the beaches collecting information about what's there. Quite honestly, cleaning up the oceans is not something that one citizen science program can do. What we can do is we can create a baseline, but also, and this is the coolest thing to me about debris, rather than understanding or writing down what the identity of the debris is, that's a lighter, that's a water bottle, what we're writing down is what are the characteristics of that debris. Is it plastic? Is it metal? Is it a fragment? Is it sharp? Does it have a loop in it that a marine mammal might be able to stick their head through? Is it small enough and in the color range that an albatross might mistake it for flying fish eggs and eat it? So all of those characteristics of the debris tell us something about harm to wildlife. And once we have that, we can literally map the entire coastline and understand which sections of the coastline and at what time of year are harmful for what kinds of organisms. And that is something that can actually direct very broad scale resource management.